Hello and welcome to the chapter 2 of the tutorials for Ansoft Maxell. As you saw in the very first video of the chapters, the introduction video, I'm going to go over different analysis and types of analysis in Ansoft, and during that I'm going to give you some examples. In that examples you will learn how to make your 3D model, how to define your boundaries, excitations, work with a couple of options, settings, and basically see which example is actually fit the most or it's the closest the most to your application, so you can easily go through that examples in this couple of videos and apply that to your application or your problem. These examples are very close by the examples that were presented in tutorial sessions that were basically held by Ansoft, Ansys, and I got some notes in the tutorial sessions. I've been actually in Ansoft and Maxell tutorial sessions. If I need to add some of the Maxell tutorials, I will also go ahead and use those tutorial sessions that I used. But as I said, these are very well worked examples that were provided by the company, and I'm gonna make the video out of those things and the notes that I had, so you can actually go ahead faster and see what's going on. So as you remember, the very first and the most simplest, if you want to like characterize what we had in the first video, we have either magnetic solution or electric solution, and based on what kind of a field the engine is going to solve. And when you have magnetic or electric, you have two other subcategories of DC or AC. In the DC mode, what we have is we have magnetic DC, and then or we have electric DC or magnetic AC, like an eddy current, or electric AC, AC conductance, and at the end we have transient, which is the most comprehensive way of simulations for both magnetic and electric way of solving that. So these are all the categories. I'm going to go ahead for the people who were not having time to watch the very first video. So now what I'm going to do is I'm going to go ahead and start an couple of examples for magnetostatic DC magnetic solve. So in this couple of examples you would learn how to solve equations for magnetic force, induction calculation. You can also see how you can calculate the current and inductance in the standard conductors, and so on. So the very first example that I'm going to go through is the using magnetostatic analyzer, and it's going to be calculating the force in a magnetic with a permanent magnet. So how much force the permanent magnet can basically put into a simple device. So with this calculation, we basically we are going to have a permanent magnet, and also we are going to determine what's the force that exerted to a steel bar, as I said, using the magnetostatic solver. So let's go ahead and start the simulation. The first thing you want to do is, as you know, you have to go ahead and create a new project. I'm gonna press F2 or right click and select rename and call it, for example, force. So that would be the name of my project. Okay, now what my project needs is a model, something to run the simulation for. So the model that you can check, for many people that asked in the channel, you have different kind of models you can insert. You can insert a 3D model, you can insert 2D model depending on your work, or you can actually insert an RM expert design, which is basically for motors and like transformers. So these are like sort of models that comes the simulation and environment is actually customized for the people who are going with this motor sort of a design. So what I'm going to do is I'm going to go ahead and insert a Maxell 3D design. Okay, there we go. So before we start, let's go ahead and check out some of the options that we have and make sure that the options are valid. So let's go to Tools and then to Options. And then let's go to the Maxell 3D options. I'm going to make sure that you guys have these options checked. Use wizards for data input when creating new boundaries. So that is good because automatically you can see the wizard and you can actually work with this and change the parameters as soon as you want. And also you want to have this option checked, duplicate boundaries or mesh operations with geometry. That would help you to have a faster basically modeling time, and it will do it for you automatically and you have less problems with your meshing. Also, I want to go ahead and press OK on that, and then I go to Tools and then to the Options and to the Modeler options. And over here I want to also make sure that the automatically cover closed polyline is checked. So make sure that you guys are checking that. That is good if you are going to have no problem for the meshing. So that actually save sometimes for you for verification of the 3D model that you have as well. Next is the Display tab, and over here you can actually play with the default transparency that you have for any objects that you are creating. That is important if you want to have objects within the objects, which was very probable. And for that reason, you want to have a default transparency so you don't need to change it each time. And with default transparency closest to 1, you can basically have full transparency, meaning that you can see whatever is inside the object. And if you have the opacity or opaque value of 0, it means that basically you can't see inside that. So as I said, the default transparency is 0, which is not very good or helpful for the designs that have different objects inside. I'm going to go ahead and call it 0.84 or whatever, and that can save the purpose. And also in the Drawing tab, you want to make sure that the edit properties of new primitives is also checked. So that means that whatever primitives that you are making, automatically an edit property windows will show up, and then you can right away check the stuff there. Okay, so that would be the options that you want to do very first. That way that actually the Ansoft is teaching. So the tutorial goes like this. So I'm going to follow that. Okay. Now, one more thing I've done here, but I don't think that you guys are doing the same thing, is when you go to your Maxell 3D, your solution type, that's where you can actually find the type that we have. So as you can see, we have magnetic and electric categories, and we want to be in the magnetostatic one. So make sure one is clicked and selected. Okay, press OK on that. And now I'm gonna switch to my here is millimeters. You guys, if you're inch or inch, you can go ahead and your unit modeler. So if you go to the model here, there should be, yes, there we go. There is a unit option here where you can go ahead and change your unit. I don't want to go ahead and explain more of this unit part, you can actually find it from the previous videos. Okay. One more thing that I always forget to do, and it is important to do, is what would be your default material. In this basically problem, we are working with the steel because it has a permanent magnet characteristic, so you can change it right away. Sorry, I did it so fast. So basically you go ahead and select that, and you say select different material, and then you go ahead and find a steel if you can find it, or you can. So the one that we have is a steel 1008 with some BH curve. As you can see, it's a non primitive permeability that we have, and that is one of the characteristics of magnetostatic. As I said, it can handle nonlinear BH curves as well. So we will select that one as a default material. Okay, so now go ahead and create the core that we are going to have for our permanent magnet. So what we are going to do is we are going to go ahead and box, and you can go ahead and just select whatever you want here, or you can put numbers. So I'm going to put numbers, so following the tutorials that I had, so you can actually see that. So what you do is you just press 0. As soon as you press 0, I don't know if you can see, down there in the X indicator, you can see that there is a cursor indicator. Because I said 0, it actually shows 0 on that. And then you press tab, you go to the next coordinate. So I'm gonna go say 0 for the Y, and for Z I want to have -5, which basically represents -5 millimeter. Okay, and then I'm gonna press enter. Okay, and then after that I'm going to have the dx, dy, and dz. You realize that when I press enter, x and y and z becomes dx, dy, and dz down there. So let's just put the values for that. In Windows, you can use Shift and Tab, which I think is the same thing in Mac as well. Also, you don't have Mac for that. So basically, you use Shift and Tab to go back, or Tab to go right. So if you want to come back and forth between dx and dy, that's how you do it. So let's put the value 10 for dx and -30 for dy, and value of 10 millimeter for dz, and then press enter. Okay, so now what we have here is the box that we created. Note that because we selected that we want to have automatically popping up the property of the primitives after we created automatically, now we have this pop-up here that says is it the values that you want? Because we entered the values, we didn't use the mouse. Yes, these are the values that we want. Okay, so let's just press OK and get rid of that. Now let's go and make this thing a bit larger. So you can actually zoom out by just scrolling your wheel, and you can see that it's already zoomed out. And there is one small problem with that. I'm gonna go ahead and make sure that everything is fine. When you enter, okay, so that's okay. So that's what you expect to have. Now I'm gonna go ahead and duplicate what I have To do that, what you want to do is you just want to select the box 1 or whatever it is, or you can just rename it to whatever you like, but I think if you duplicate it and then rename the group is better. So you just select the box 1, and then you can either use this button here that says duplicate here. Sorry, what I'm doing. Excuse me, here, which says duplicate, or you can go ahead into edit and then find duplicate. Of course, you want to do it along the line, so I'm gonna select that. So now you have to select which coordinate for the line and then how much do you want to duplicate. Again, you can just select here. As you can see, if I select here, it automatically is snapped to the 0, 0, 0. So I'm gonna use mouse for this purpose and just click. When you click, you can see in the lower bar we have dx, dy, and dz. So now we can enter the dx, dy, dz that we want to duplicate. Very simple. So I just put the number 30 automatically. 30. And you can see that the dx is 30, dy is going to be the same 0, and dz is the same 0. Press that, and the total number of that is going to be 2, meaning that you have the original and you have this one. Okay, that's okay. And as you can see, because of that options, we have this automatic pop-up. I just say okay, and everything is good. Okay, I'm happy with that. So, and these are the two boxes that we have at the moment. Now, let's have another box, and this time I'm gonna not use the mouse. I'm gonna just enter the values. So you can do the same thing. You can actually use the mouse. It just snaps to the points that you want, or you can just enter the values if you're okay with that. I'm gonna enter the values. I have 0 for the x. As soon as I type it, it goes down there and shows that. For y, I have the value of -30, and for z, I have the value of -5. Okay, I press enter and go to dx, dy, dz. For the dx, I have 50. Sorry. For dy, I have -10. And for dz, I have 10. Now I can press enter. You can see that it shows a preview of the cross section of the box that we are going to make. So I'm going to press OK now. And again, we have this bar. I'm okay with that. Is that good? So now you should have a shape like this. This is what you will end up having. Now, as you can see, we have an object that has connections between, like, we have like these two parts are facing each other. For modeler, it's a bit hard to understand that is it going to be deliberate, touching each other, or they are like super accurately putting next to each other and there should be like whatever material in between. We want it to be deliberately exactly touching each other and there's no materials in between. So to understand it better, for to make it better understandable for the Ansoft, what we are using is one of these features that's called unite. So when you unite the objects, it's actually telling the Ansoft that, dude, these guys are all connected to each other. Do not bother to see what is in between these two. They are fine. They're all one unit. So I'm going to go ahead and do the old-fashioned way. I go to the edit, and then I will go to the select all. So that way I will selecting box 2, box 1, underline 1, and box 1. And then I go ahead and select unite from this menu this time. Or you can go to the modeler, Boolean, unite, one of these two methods. There we go. So now what we have is a unite shape which is called box 1, which I guess we have to change the name of that to core. So this is what we have. So let's change the name of this. There are many ways that you can do that. You can double click on that. You can go ahead right away here in the property windows and in the name section and change the name there. And whatever you choose, that works. So I'm going to go ahead and change the name to core. Press enter. So now the name of that is core, as you can see here as well. And the material that we have for that is a steel underline 1008, and everything else is the same. Now if I want to have this core mirrored, I can also do that. So I can have a symmetric coil. So how I can do that? I select the core and then I go to the edit, or you can use the mirror here, but I'm gonna do this way because many people can find it more instructive. So I go to edit, then I go to duplicate, then I go to mirror, then I select mirror. So now, as you can see here, control click to change the reference and all these things. You can actually again put the numbers or just select. I can just select the 0, 0, 0 like this, and then it automatically becomes dx dy dz on the bottom right. So I'm going to put the dy dz and dx, the values that I want. So sorry, my mouse just changed. I don't want to use my mouse, although I can do that, but that's not good. So let's just use the values that I want. I want 0 for dx. In fact, I want 1, not 2 for dy, and I want 0 for dz. That's a good thing when you put the values, because it exactly goes to the place that it should go. Okay, so now we have two objects touching each other, and guess what? Same idea. Because they are touching each other, we want to make sure that the Maxwells understand that these are one object. So I'm gonna go ahead and select them all, and then I'm going to go ahead and unite them together. So this is unite. Sorry, I'm gonna go ahead and use this option. So where should I find unite? That would be in the Boolean options. There is a Boolean. Okay, now it should be in the modeler actually, I think. Yes, Boolean and then unite. There we go. So now we have one core, and it's very wise, and it understands that core 1 and core underline 1. Just rename it to the source name, the core. So now we have core, and we have this beautiful shape. Let's now create a bar that we want to see how much force is going to be attached to that. So this is our magnet, permanent magnet, and it's going to suck up a bar. So again, we go and draw a box. I'm going to just put the numbers. I'm going to say 51. Okay, 51 for x minus 40 for y and minus 5 for z. I press enter, and for dx and dy and dz we have the values of 10, 80 and 10 respectively. Press enter, and you're satisfied with that. Press enter that. Now you saw that you don't have all the options you want. If you go right here, you can see that you have more options. First thing that I'm gonna do, since it's selected, box 3 as you can see here is also selected, I'm gonna go ahead and change the name to bar. Okay, so now the name is bar, and I'm gonna go ahead and change the color to something that I like. I like maybe green. I will go with green. If I like this one, I will go with this color. It's a very weird color for a bar, but let's see. It's like like a bar of butter. So there we go, we have it. So now we have our bar as well. And let me just double check everything is fine. Okay, now if you want to do a good simulations, let me just show you what I'm trying to talk about. If you want to do a good simulation, you want to make sure that you have the options to parametrically change your geometry without going each time redrawing that. So how you can do that? Let's say that you want to go ahead and change the distance of this butter bar from this magnet. So in order to do that, as you can see here, there's a distance. I'm going to go ahead and click on bar and then double click create box, and you can see the same familiar automatic pop-up edit windows that always shows up after we create the print. Over here you can see that the 51 for the X directions, which is green axis here, which is the same directions that we want to move, is 51 absolute value. So what if I want to make it not absolute value? What if I want to have it some movement? So I would say plus some variable. I want to call it mx. Okay, that means that I'm moving it in the x directions. One thing that I realize is you have to always be careful when you put 51 plus mx. For some reason it mess up with the unit. So just put millimeters next to the 51, although there is a millimeters here unit applying to all these numbers, but when you change it to an expression, it somehow doesn't understand that. So just say 51 millimeters plus mx, and then when you go to the next, it automatically asks you that you adding a mx into your expression, and I don't know what mx is. Is it a new variable? It is a new variable. What is the unit of that? We say it's length. I just press L and it goes automatically to length. Is it in millimeters? Yes. What's the value of that? I want to say the value of that is 1. Okay, so that's 1. Press OK. I can change the value later on. But one thing that you have to take care of is look at this. It automatically evaluated, and it is 51 millimeters because added with 1 millimeter it becomes 52 millimeters. Everything is fine. And as you can see, the unit part here is somehow missing, and that's the weird part about that. But everything is fine at the moment, and if you change the value of mx, you can do a parametric sweep and you can automate it, and you can get a great result after that.